Good morning, ladies of Precalculus and Bryce and Jose. Welcome again to Room 15, where? It never ends, and does not even end when I'm gone, does it?
No, it doesn't.
Because Mrs. Peavy's here, and you were working on your assignment.
She was the best one we've had, probably.
Oh, really? You liked having her? Good.
Yeah, we like her report. Thank you.
I know the classroom is in good shape, I felt, here, so. Thank you for doing that. I saw her last night, she didn't say anything bad about this or any other classes. What happened is, the jury pool I was assigned to was covering, it's called the petite jury. And what it is for small cases, it'd be like a jury of 6 people to try traffic violations, court, or some kind of a misdemeanor, city code ordinance violation, something like that. But they didn't actually have a need for a jury yesterday, but I had to wait as long as I could possibly be needed. So I had to wait for 2 hours before I got dismissed. So that's what happened yesterday to me.
Did they give you food?
No, I didn't get any food.
What?
That's all right.
Where'd you have to eat usually?
And another thing about it was, so I didn't have any, I wasn't given any food, so I couldn't cheat. The way I could have cheated, but I would have had to use a vending machine, right? Which I didn't do.
You cheated when he was at the game, maybe. Just maybe. I don't know.
No, because at that hour it's not cheating anymore.
Oh, yeah.
Yeah. So if you see me at the games there, you can't catch me cheating because that's acceptable hours.
Yeah, I agree.
Yeah. So anyway.
Mr. G, you just had to wait outside the courthouse?
Probably inside the corner.
Yeah, it was inside the courthouse, but I'll tell you where I did have to wait. I had to wait at a bus stop when it was cool outside to get a bus ride. So that was it. So that was my waiting. And on the way back, I had to wait about a half hour for the next bus to come. They don't come as frequently during the middle of the day. So I had to wait out. It was pretty cool. And there was, outside the bus stop, I took a picture. There was some writing on the sidewalk. You know what the writing on the sidewalk said?
What did it say?
God is not dead.
Amen.
Yep.
So I took a picture of that. So I'll show you that sometime.
Okay.
That was writing on the sidewalk. So I thought that was. So that was good, right?
Yeah, that was great.
And it was really a good message for things that were happening to me that day too. So let's look at this one right here. So we're going to evaluate these without a calculator, and I only have 6 exercises on this sheet. This might take the time of the classroom anyway. And how can you evaluate something without a calculator? You remember problems 1 through 18 yesterday, they were without a calculator. Well, I guess you could have used a calculator if you want to take the square root of 170, right? Find out what it was. But how do you do these problems? How are you going to do these problems?
Well, you know that sine is opposite over hypotenuse.
Sine is opposite, so we know it's opposite of hypotenuse. What about the angles? What about these angles? What kind of angles do we have?
What angles?
Pi over 3,
Oh, the radian.
pi over 4, pi over 6, pi over 3, pi over 4, pi over 3. So what are these angles? What's the significance of these angles? All right, I want to show you something. I want to show you your Acp Formula Chart. Right. Do I have it here? No, I don't. No, I don't. Okay. So I'm going to show that to you. I thought I had that up. Well, there it is. Man, I thought I had it up. because there's something that's very important on here that's relevant to these exercises.
It's impressive.
Hey guys, let's all put our energy into this.
Learning never ends.
Okay,
Learning never ends.
three.
One,
One, two,
2, 3.
I can't.
Oh, that was so bad.
You were all
You were all,
put
it
it
didn't work,
worse.
you were all, okay,
Ready?
on three. One, two, three.
Oh.
There it is, it's right
I
here.
thought we were going all on 30.
So it's a read-only copy, so it's saying that it was already there.
Right after 13.
Anyway, we look at our trigonometric functions and identities right here.
Yes.
So we see them right here. And the thing that we're dealing with today are things called special right triangles. Because,
So why are they special?
I'll tell you why they're special, but do you remember the unit circle trigonometry song?
Unit circle trigonometry.
Look at the start of it. 0 pi over 6 and more. The next one to know is pi over 4 and pi over 3 and pi over 2. All the radians I'll say
to you.
r is one circumference is pi times 2. 0, 30, 45, 60, 90.
That's
why I love
why
you circle trigonometry.
trigonometry.
0, 30, 45, 60, 90. That's why I love you circle trigonometry.
This video needs posted.
So what we have is these are the standard, these ones on the unit circle, like pi over 6, pi over 4, pi over 3, pi over 2. These are all standard unit circle trigonometry angles which correspond to 0, 30, 45, 60, 90.
Oh.
Right? So this one here is going to be sine pi over 3. If we change pi over 3 radians to degrees.
0, 30, 45. 45.
So what's pi over 3 going to be?
45.
Is it 15 or
0, 30, 45.
0, 15, 30, 45? No.
60 degrees.
Mr. G, why? 30, 45,
0, 30, 45, 60, 90.
See, 3. Your third finger was 45.
0,
30, 45.
0, 30, 45, 60, 90. Okay, these right here on your hand, let me show you.
Name your finger.
You 0, 30, 45.
Okay, you have your hand here like
Yes,
this.
yeah.
You have your hand like this. I'll just draw, here's the middle, here's the other finger. And your thumb is up like this. So you have your hand right here. You got, that's 0. That's 0 degrees,
0 degrees,
30 degrees.
30 degrees, 45.
This middle one here is 45. This one up here is 60 degrees. And up here, this thumb that goes straight up like this, that's 90 degrees. So that's 0, that's pi over 6, 30 degrees, pi over 6. Pi over 3 is up here. And so all these angles that we have here that are in quadrant 1 of the unit circle are going to be these 30, 45, or 60 degrees. Right?
I just I don't understand why pi over 3 is 60 if 0 is 1, 30 is 2, and 45 is 3. 5 3.
Pi over 3, we want to convert it to degrees, we multiply by 180 over pi.
Right. Okay,
Okay? That's this right here.
I gotcha.
And I'm also introducing this because this is a hand trick of unit circle trigonometry. Remember, what was,
So it's, just tell me what each, like, pi over whatever width, like, means, because,
okay, this right here is your pi over 6.
so pi over 6 is 30.
Pi over 4 is your 45.
Pi over 4.
Pi over 3 is 60.
Okay, and so pi over 2 would be 90?
Pi over 2 would be 90.
Okay, got
That's straight up here.
it. Understood.
And do you remember we had we had some hot chocolate last week, remember that?
Yes.
And then I give you this,
2 is 90, 3 is 60, 1 is 45,
45, so 30, okay, so,
That's 4 and that's 6.
yeah.
4, 6.
did we use this cup
3.
last
Yes,
week?
we
We
did.
did,
Look what
right?
Jacelyn did.
Oh, she wrote on your hand?
Yeah, I did.
Now, the thing about it is, what this is, what I encourage you to do is use your left-hand corner of that exactly. Did you write it on your hand?
Yeah, she
So
went like
that's really
this.
good, huh?
She went like this at the board.
So what it is, on your hand, you're trying to set it up so you look at it, so it's a guide for you. 0, 0, pi over 6 and more, next one was pi over 3, pi over 2. So you can see these on your left hand,
Okay.
right?
So-
Right.
So that's your representation of your points in the unit circle of your circle trigonometry. right
Yes.
here. And see, it's right here on our unit circle
Wait,
trigonometry.
you need that hose.
See? It's right here. See that?
If I was doing this on like the SATs, would I get proper cheating?
Yes.
I don't know if you would or not, but
What if I got it legally tattooed on myself?
I
Yeah.
don't know.
Would that be
Be
cheating?
careful about it. Be
Well, you know,
careful
there's
about
those like, the.
it. You should be able to know what it is without writing on it, right?
Right.
Should be
Yeah,
able
we
to-
should, we'll all do that just for somebody here.
Yeah. One thing I have is I have my unit circle trigonometry T-shirt. People said, what if you wear that to your test? You have it on your.
0, pi over 6 and more. The next window is pi over 4. Pi over 3 and pi over 2 are all the radians of safety.
Okay, now, the reason it comes into your ACP formula chart is this. Where it comes into play is this, let me show you. You come right here, and you see where it says special right triangles,
Yes, I see it, Mr. G.
30, 60, 90. You have x squared root of 3, 2x. And for 45, 45, 90, you have x squared root of 2. See that?
They're both special right triangles?
They are both,
Okay.
And so these are the ones that you are held accountable for. And these ones are part of all these angles, 30, 45, and 60 degrees. So we're going to go ahead and explain briefly, I hope briefly, what it is. So here, if we have a 30, 60, 90 right triangle, which is something like this, it's not drawn to scale, but we'll say this is 30 degrees here, right? And we'll say this is 60 degrees here. And what it says on your formula chart, it says x squared root of 3, 2x. See that?
Yes.
So x is your small side, x squared root of 3 is your next side, and 2x is up here.
You just picked random spots for those, or you know that that's where those go?
I know where they go, because 2x is going to be your hypotenuse
2x
I feel like it'd be a lot.
always going to be your hypotenuse?
for a 30, 60, 90, yes.
30, 60, 90. 2 is
And-
always your hypotenuse.
And x is going to be your short side, this side here is going to be x squared root of 3. So it's this. So this tells you your proportionality of the sides to each other.
Yes, okay.
And then, so we want the sine of 60 degrees, and so we need to find the opposite over, so the sine of pi over 3 is going to be the same as sine of 60 degrees. And so it's going to be, what is sine going to be? Your sine is opposite over hypotenuse. Thank you, Lexi. So we got opposite. So I'm going to put x squared root of 3 over hypotenuse. And what is your hypotenuse? 2x. Can we cancel anything here? X over x, right? So our answer is going to be square root of 3 over 2. So as a summary statement, we could write sine of pi over 3 is equal to square root of 3 over 2. And this also comes back to the unit circle trigonometry song. 0, let's see, 0, 1/2 and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2 and 1, the sine is the height at any radian. The square root of 4 over 2 is 1. So I'm going to say it again. 0, 1/2 and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2, right? That's 60 degrees. And 1, the sine is the height at any radian. So that is the height at any radian on the unit circle.
Can you sing it again, Mr. G?
With the guitar and everything?
No, can you just sing it? Just sing it like just the stanza that you just sang. Can you sing that again?
0, 1/2 and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2 and 1, the sine is the height at any radian. The square root of 4 over 2 is 1. 0, 30, 45, 60, 90. That's why I like circle trigonometry. That's it. Okay? So that's that one. Okay, and then for number 20, we have a different type of right triangle, which is what? The
other one on the formula chart.
The other one on the formula chart, exactly. So let's go to that one.
Is that one not for, oh, that's for 45, 45, 90? No, this one was for 30, 60, 90, and then the other formula is for 45, 45, 90?
Yeah, so anyway, here's drawn out a 45, 45, 90. So there's your 45 degrees, right? And this is 45 degrees here. And then on your formula chart, it says you have the relation to each other is x, x, x square root of 2. So this would be x, x, x square root of 2. Okay? And so this is going to be the same as, if we change this to degrees, it's going to be the same as the tangent of what?
Opposite over,
45 degrees, right?
wait, I don't even know what you asked. I just.
Okay? Again, 0, pi over 6 and more. The next one to know is pi over 4 and pi over 3 and pi over. So this pi over 4 is the same as 45 degrees, right? So it'd be representing your middle finger and the hand.
And that's how you know that tan equals 45 degrees?
Well, tangent is, so we have this, and so what is tangent in trigonometric ratios? Tangent,
Or opposite over adjacent.
so tangent, so we know that tangent 45 degrees, and what's our opposite side here?
What are we oppositing from though? I don't understand like which one we choose.
45 degrees, right? So x over x,
Yeah.
which simplifies to 1. So summary statement, we say tangent of pi over 4 is equal to 1.
Is it always like that then? Since, I mean, any pi over 4 that's tangent is going to be 1. Because pi over 4 is 45 and so.
Yeah, yeah.
And so, Mr. G, the other one, when you said it equals 60, does it equal 60 because pi over 3 is equal to 60?
Yeah.
So the other one was sine 60 because pi over 3 is 60?
Right, yeah.
Okay.
Yeah. And one thing I'm going to do to you today too, I think it's a good time to hand it out.
Over pi over 4 you say is 45.
Mr. G,
When they're 45,
Yes.
it's just.
how do you know where the 45, like how do you know it goes on the bottom? Because like on number 19 it went on the top. How do you know where to put it?
Well, you have to look, you can look anywhere. Like if you go back to number 19, number 19, you look for where 60 degrees is. It's going to be right here, right?
You do it from
But how do you know that?
So there's 60 degrees right there. And so the opposite side is going to be over here. So here's your opposite side. Here's your hypotenuse is up here.
Like, why don't we get 60?
And this is your adjacent side here.
You just pick the
One angle is 60.
Okay?
smaller, yeah.
Or another way you could draw it too, you could draw it differently, and a unit circle would show up like this. It would look more like this. You'd have your 60 degree here, right? So there's your 60 degree over here, and then this is your hypotenuse here. This is your opposite here. And so this is going to be, in proportionality, this is going to be x squared root of 3. And this over here is going to be like 2x.
Gotcha.
So x squared root of 3 over 2x, that's number 19 worked out. Okay, this one here, we're going to have your tangent is x of 45 degrees is x over x, or 1.
Mr. G, can you do number 21?
Yes, I can.
Because that one, how do you know which formula to use? Because both of them have 90 degrees in it. So how do you know if it's the x squared root of 2 or 2x, x, and x squared root of 3?
Well, I know this is going to be cotangent of, the same as cotangent of 30 degrees.
Oh. Oh, I thought it was 90. Okay.
And cotangent is the opposite of tangent, so
It's reciprocal of tangent.
Yeah. So it'd be adjacent over opposite. You're just supposed to-
Adjacent over opposite, yes.
So are we still drawing the like right triangle thing or?
That's what I would do.
Okay.
Yeah, you can do this different ways,
So
but
it'd be
that's what.
How do you know it's odd 30 degrees? 'Cause
Okay, I'm going to give you some unit circles you can work with.
I just recognize that pi over 6 equals 30 degrees.
So, Mr. G, this one would be the first formula, the 2x, x, and x squared root of 3 one?
Right, yeah.
Yeah, so when it's adjacent over opposite, it'd be x squared root of 3 over x.
Yes.
And so then it'd just be cotangent,
Yes.
cotangent 30 equals square root of 3.
Square root of 3, yeah.
Yes.
That's it.
Because x goes out.
Cotangent is opposite over.
Fact.
No,
Tangent is opposite over adjacent, so cotangent is reciprocal, so
Right.
adjacent over opposite.
Right.
I just wrote some stuff.
Yeah, same, but then I still.
Your class is
didn't
going to
see it. I didn't
get
see
some
it.
orange ones.
It's the same.
It's the same, but I can't remember the one.
Yeah.
I just.
Okay, what I want to do for this one,
Break them up.
Call on somebody.
I already know who I'm going to call on, because I already heard her explain it.
Okay, so. So secant goes with cotangent, or like, not cotangent. Secant goes with
Sine.
No, cosine, yeah.
Cosine.
Yeah.
Okay.
Yeah.
The one I want to put this up here, I want to have CF go up here and do this one, because CF was explaining it, I thought, quite well. So I think that would be quite helpful to the class to have her do it.
How do you know what's right here?
So now I drew one
Because there's not a plane.
This is 30. I think this is too bad.
Well, no, minus.
Yeah.
Because it's like usually to because yesterday all we were
Okay. All right, CF, if you can go ahead and explain to the audience there how you got all that and where you got all these things from.
All right, I just know now that pi over 6 is 30 degrees, so cotangent 30 degrees. And then I drew the triangle, and on our formula chart, it says when you have a 60-30, so this would be the angle that we gave is this one, so this is opposite and this is adjacent, because 30, that's just the angle we're looking for. So when I found cotangent, which is the opposite, or the reciprocal of tangent, and tangent is opposite over adjacent, so you just reciprocal it, and then you get the adjacent over the opposite. And then you just simplify it.
Good
All
job.
right. Did she explain it pretty well? I thought she did. I thought she was really good, right?
So where did?
And so I heard her explain it. This time she explained it with a picture of it.
So whatever number it gives us is like the
The angle,
data.
yeah.
Right, that's what I was thinking. Okay, that makes sense.
Okay, all right, are things brightening up here a little bit?
They
A little bit.
certainly are.
A little bit.
Okay, good.
Oh, yeah.
But this thing, what you're doing, this whole radians thing, that's a whole new piece of vocabulary, isn't it? And looking at it. So it takes some time to sort of get your mind wrapped around this, I think.
I know that 2x
That's why I love you when circles are getting
how do you know? Because x and x squared to 3.
I just put it like this.
Me too.
I just,
If it's a triangle, face it.
the other way, I think it's the same thing. I just always have this one.
This is just secant of 60.
Okay. So now we have secant of pi over 3.
That's what we're trying to figure out. Like, how do you know where the x raised to 3 and the x go, like on which side? Because on the 45, 45, 90 triangles, it doesn't matter. But on this one, it does.
I think a 30, 60. I'm just like, I think.
Okay, for number 22, we have GL.
Who's that?
Every time I hear those names, like, I feel like in my mind, like, I had to do that last week. Like, every time. I don't know why. So I heard this and
You guys haven't heard about all of us.
I don't remember what happened.
I got secant 60 equals 2.
That's what I got to people.
Yeah.
Yeah. That's extra stuff.
So would this degree go on the top of this here?
Yes, because 60 is our theta.
Yeah, 60 is our theta, because you know how yesterday we were like writing tangent theta.
Whatever,
So
okay,
whatever.
so secant 60 is where we're looking at a triangle to go, like, so this would be opposite and this would be.
And you know it's on top because you know the other degree has to be 30 and it's going to be on the top. That makes more sense to me. Because me thinking it's just looking at it being bigger, you could draw it different ways and it could look bigger. That makes, I don't know why.
So she's drawing her pi over 3 triangle, right?
Did you figure out why it's 2x? Or
I haven't found out. I mean, you might want to ask him about
So, yeah, problem, it's like, the heater's going right now, it's just like.
The heater feels really nice.
It does, right? This is where Sarah has a hard time with her job.
It starts for the day. It started in this class every day.
So cosecant.
Yeah, these cold days,
Yes.
Did you just say?
it's hard for Sarah to do her
He
job.
started sneezing in this class.
So did you get 2 over the square root of 3?
X, 2x?
For now, it's working better.
I can't remember, like, 2x, x was a very 69, so it's 2.
Well, no. 2 is for 30, 60, 90 is 2x.
2x, yeah.
It'd be 2x over x.
2x, yeah, so 2x over x, yeah.
So 2x
Okay.
and then the x cancel out, and then it's 2 over.
All right, so she has secant of pi over 3 is equal to 2. Does that sound right?
This one, I got the
Yeah.
other x because it's 60 in this
Okay, let me show you.
60 is,
You have,
Oh, this would be the opposite.
Yeah.
which was 60.
opposite, adjacent.
Mr. G.
So it'd be 2x over 2x.
Hey, so can you give me a jacket a little bit of sort of this?
I got x over x squared.
Yeah,
So it would be square root of 2.
I thought when it was on the bottom, that was like 1 over.
I thought that this just canceled out.
sorry?
The 2x's just canceled out, I thought.
Or meaning,
Or is it?
opposite over.
I thought it looked this over here, so like when this is over here, this means the top is 1.
So is it 1 over square root of 2 or just square root of 2? Because I thought they canceled out, but Chloe said that there's like
Since it's on the bottom.
there's a 1 right here, so I don't know.
Okay, there's one T-shirt that some of you have that says there are cosecant,
1 over 1 times that.
5 pi over 6 kinds of people in the world, those who understand trigonometry and those who don't.
Yeah.
Well, this one, we can make another T-shirt.
So if it was.
There are secant pi over 3 kinds of people in the world, those who understand trigonometry and those who don't, right?
Yeah.
It would just be.
So that's another T-shirt design possibly we have here, right? There are secant pi over 3.
But if that's isn't.
It's going to be your
If it was like 6.
sine. Well, it's going to be the reciprocal of cosine. Cosine of 60 degrees is 1/2. Reciprocal of that is going to be, yeah, cosine is going to be that, no, that over that. So reciprocal is going to be that over that. Okay?
Yeah, I don't know if it's the 1 over
I
9.
think what she's saying is right.
That's what I think too. Because if, how we did it is like if
Okay,
x
cosine
was
pi
1,
over 4.
then it would make sense. I just didn't think about that.
At first, I thought it was just.
Because I just thought they canceled out. But if x was 1, then x times square root of 2 would just be the square root of 2. Huh?
So I think we've had that conversation before too. How it ended up.
Guys, please, I'm trying to focus.
Okay, there, for next one we have here is,
Hey, what do I need for 23? Like a final?
Cosine 90 equals 1 over.
we have JM.
23, yeah.
Cosine 90?
It's JM.
Cosine,
Cosine 45.
Yeah.
cosine 45.
That's what I.
1 over square root.
Jose!
Wait,
up there.
where'd you get 1?
Yeah.
Because wouldn't it be x over x square root of 2 and then you would cancel the x's and then it would just be.
That's,
Where are you
When they cancel out,
We
it
don't
just has
know.
a 1 in the numerator.
we don't know.
And just like when it cancels out and something's on the top,
This
it's
is
a
the
1 in the
argument.
I
numerator.
don't know.
This is the argument.
You can't take it out.
I got you now.
So something stays, it's just like when it's in the top,
Okay,
like when it's
Mr.
in the
G,
numerator.
before I get up here and do it wrong,
you
you wanna check my answer on that one?
Just ignore it because it just doesn't mean anything.
Yeah, we're going to clean it up too, though. Go ahead. I drew it up there.
Did you just memorize, Chloe? Pi over 3 is that, pi over 4 is that, pi over 2 is that?
If you forget, Abby,
Yeah.
if you forget to put it in your calculator, it'd be 180 divided by like the number.
And it'll give you 45, 60 or whatever.
Yeah, so pi over 2 would be nice.
Yeah. I like when that. No, yeah, that's all of them.
So pi over 2.
Pi over 2 is.
Yes.
Yes.
Was 180 divided by 2.
Good, so,
This is pi over 6, pi over 4, pi over 3, pi over.
so basically what you have,
6, pi 4, pi 3. This,
you got adjacent over hypotenuse, right?
this one, just not.
It's going to be x over x squared root of 2. What cancels out?
45.
That. So you get 1 over square root of 2. Now, one thing you do in these,
4 is 45.
if you think of the unit circle trigonometry song, which is cosine, right?
2 is.
The x's are 1, square root of 3 over 2, horizontal. They must be square root of 2 over 2.
What is it?
and next are 1/2 and 0, so square root of 2 over 2. How do we get from here to square root of 2 over 2? Well, you multiply by square root of 2 over square root of 2. And what you have is square root of 2, you call this rationalizing. In the numerator and denominator, you have square root of 2 times square root of 2. So we're talking about square root of 2 over 2. So sine and cosine.
How can you do that though? How can you just multiply that on one side without multiplying it on the other side?
It's not by one side and the other side.
Well, I mean, but
It's a
how can you
numerator and a denominator.
then you're just multiplying it.
So you're multiplying this by 1. This is a multiplication by 1.
So why can't you just leave it? Because then wouldn't it not be
Because you don't want to
simplified?
square root.
Yeah, what it is, by convention, you don't want to have the square root in the denominator. So
Why?
you rationalize it. That's just because somebody thought it was a good idea. And look at your unit circle trigonometry chart, right? Look at your unit circle right here, over here where it says pi over 4. You have, your coordinates are square root of 2 over 2, comma square root of 2 over 2.
So anytime you have 1 over the square root of 2, it's just going to end up square root of 2 over 2.
Yes,
Okay.
exactly.
You have to rationalize other things if you get a square root in the denominator?
It depends on what it is. Something like unit circle
What is,
is very helpful because
I usually don't know what
it is, it's sort of a conventional, that's what it is.
And the denominator of that one it is 2 over square root.
Mr. G, can I go?
And then we have the next person is going to be,
And Alice Collins here, though, she wants to go.
she may be the chosen one here.
2 times
see.
square root of 3.
We'll see if her name's still available, then I'll choose her.
Whatever that is.
How's that?
Or 2.
Okay, all right, you're okay to go.
Whatever.
Okay,
I'm
good.
returning you now.
You're okay to go on that one.
Did you want to go that bad?
That was next, so we ended up with this. So conventionally, you don't have.
I'm not gonna drive the
Right,
truck.
we're gonna apply those standard units on square root of the denominator.
Okay.
Okay.
Just gonna do it.
Apply this by itself, right? So technically 1. So what is the square root of 3 times square root of 3? It's just
I thought it was 3, because the square root of 2 times the square root of 2 is 2.
Okay, so then that's just 2 times the square root of 3 over 3.
How was your brain working?
But it's not.
Unless two square roots that are the same thing multiplied together are the number without the square root, then,
Yeah.
yeah.
Wait. Why are you writing this?
You're questioning you.
So anything like that.
Alright. This was on the wrong,
So
I just wrote
that
that.
equals 2 times square root of 3.
Okay, now Atlee, you need to.
Rationalize it,
Yeah,
you need to rationalize it.
Hey, you got it, just keep going.
Yeah,
Just keep
you got
going.
it. So multiply both the top and the bottom by the square root of 3.
She's got it. Wait, what?
Yeah.
Yes.
No, we were talking about it earlier, and that's what we ended up, but since the last one you
So
don't.
it's not that?
Well, it is, but you have to multiply it now and rationalize it like we did the
So
last
it'd
one.
be, seriously?
Yeah.
Yeah.
So multiply both the top, the numerator and the denominator by the square root of 3.
Oh, right. So it's the
Yeah.
bottom.
Yeah, and so then you just have 2 times the square root of 3 over 3.
Yes.
Yes.
Okay, that's.
Yeah. Good job, Ash.
Oh, there you go. I don't know if I understand the last part, but.
You just.
Did I write? Okay.
He just doesn't, he said that no one wants, you don't leave it with the square root and denominator. So you just multiply by technically 1, but it's both of them. And any square root times the same number without. So, and yes, the square root of 3 times square root of 3 is always 3. You have square root of 6 times square root of 6.
Mr. G, do you not think we're right? Mr. G, are we not right?
Well, they say 2 over square root of 3, but they didn't rationalize it until it was what they did.
Whoa, the book made a mistake.
They didn't rationalize it?
You're kidding.
Ooh.
They have 2 over square root of 3.
But that's right though, like when you rationalize it.
That is right, huh?
They didn't rationalize
No, you can look,
it.
you can look right here. Where is it? Here. 2 over square root of 3.
They didn't rationalize it.
Oh, well.
That's a square root in the denominator, Mr. G.
Yeah, okay, good job. So you guys actually did better than the book
Nice.
on this one.